Yeah, I will talk briefly about the company and some other stuff that we do outside of room correction, even if the main focus, of course, will be room correction. I will talk about the new Dirac Live software, which looks quite a bit different from what AudioControl launched with back in the days. And of course, the new base control module, which is supported by all of the new AV receivers from AudioControl. So we are about 90 employees at Dirac Research today, and 20% of those are PhDs. We are and have always been a really research-heavy company. It was founded back in 2001 by researchers at Uppsala University and at the Department of Signals and Systems, looking into signal processing methods for the LTE standard that later was called 4G. So telecommunications, really. And this group of people also had a very keen audio interest. So they thought that, hey, we have all of these really advanced methods for dealing with wave propagation. We should be able to do something with that for audio as well. And off they went, and it turned out to be the case. And since then, really, research into audio has been continuing, and the applications today are quite few. I have been with the company for 8 years, and it's been a fairly wild ride. When I joined, we were 6 people in the office, not 90, and we were only based in Sweden. So today we have presence in Sweden, Denmark, China, the US, and during the last 6 years, we have grown by 10 times, and we want to grow another 10 times for the next 3 if everything goes according to plan. And as a research company, we do have a lot of patents across the world. Patent law, that's a thing on its own. And just to try to illustrate how diverse the company is in terms of our customers, at least. Well, of course, you know AudioControl, you know NAD and the AV manufacturers, but Volvo, they are a customer, BMW. Other logos that you may or may not recognize here are OnePlus, Huawei, and Xiaomi. All of them are really, really big smartphone manufacturers. Then you have companies like Denso 10 that are a supplier to the automotive industry. So we are in most places where you will find a transducer, and we will have something that is probably a good match for that type of system. A few examples. Smartphones, that's something that we started looking into, or actually we had the first business in 2013. And today that is our largest revenue source, and we are annually in about 200 million units, which is quite a few. And what are the benefits then? Because it's of course something totally different from room correction, and it's, well, what's important for a smartphone? You want to hear people, what they say. These days people tend to listen to music or watch YouTube or even Netflix using the built-in speakers. So audibility is important. Trying to get bass out of a transducer that is maybe 9 by 14 millimeters, best case. Controlling distortion, that type of thing. We also have business in the automotive side. We have been working mostly in the high end, and that is probably changing moving forward. And that is a type of business that is going to be quite familiar to installers in the home theater space. Think of a car with a, well, better audio system as a massively active multi-way systems, where you have things like active tweeters and active mid-ranges. And then you also tend to have way more output channels than input channels, and somehow a tuning engineer needs to make all of this sound like music. All right. And one common denominator for basically everything that we do, and this is most certainly the case for room correction, is that it's based on measurements. Now, measuring sound quality, that's a fairly tricky proposition. And to illustrate this, if we look at these two plots, for instance, they show some kind of amplitude as a function of the frequency. How much energy is available for a particular frequency. And in this case, it's two different speakers that are placed in the same position and measured in the same position. So since the two plots are not the same, the speakers are not identical. So they are going to sound different. We know that because the plots are different. But how are they going to sound different? And which one is going to sound the best? That's not at all as easy to answer. Furthermore, everything we hear isn't really present in this view. Just to take a fairly ridiculous and extreme example, how about if you took the red speaker and then you built something that's identical to it, except that it's going to play all music backwards? How would that measure? And the answer to that is that in this plot, it would measure exactly the same, because the amount of energy in each frequency doesn't change just because you play a song backwards. So what is missing here in this plot is the timing information, or if you talk about it in the frequency domain, information about the phase of the system. Another way to try to measure a system like this to understand the characteristics is to look at it in the time domain. And then typically people start talking about impulse responses or the transient response, two names for the same thing, or the step response. And the impulse response is what you will see on the output when you insert an impulse. And an impulse is a signal which is 0 everywhere except for one point in time where it is a 1. So it's really just a single, really, really brief click, if you will. And okay, so if this is a measure about how does the system behave, what do we want it to look like in order to say it's going to be good? Well, good is maybe different for everyone, but in pursuit of the perfect system, I guess the ideal one could be said to be a system that doesn't actually do anything to the signal. Whatever you send out on that speaker cable is what you want the listener to hear. And as such, the impulse response for that system should be an impulse. What I send in is exactly what I get out. It doesn't change anything. And in that regard, the impulse response is quite nice, because if it doesn't look like an impulse, well, then it did something to the system. So what we see in these two plots is the impulse response of a speaker in a room in multiple positions. And the lower plot is what that looks like after we have applied Dirac Live to it. So we have much more energy in the initial attack of the system, and it dies out a lot faster than the untreated one, meaning this system will sound more distinct because you have more energy in a shorter amount of time. And none of this information is present in a plot like this one. Here we can see that the red speaker has more bass than the blue speaker, and the blue speaker has more high frequency extension than the red speaker, but we don't really know what they sound like. And of course, interpreting an impulse response and understanding what it's going to sound like is basically impossible for a human. But using mathematics, it actually contains more information about how does this system behave. Another thing that often comes up when you start talking about this is talking about the phase of the system. And what Dirac Live tries to do is to make sure that the system is as close to minimum phase as possible. And the definition of minimum phase isn't really helpful at all, but it basically means the system that is the fastest or has the least energy delay And looking at these two example impulse responses, if you only look at the magnitude as a function of frequency, they look identical. But in the time domain, we can see that they are clearly very, very different, and they sound totally different too. And this is a more heated debate perhaps in the world of DA converters and such, where people, some say you want linear phase, others want minimum phase. But it does make a difference. And again, this information is not present in your typical measurement plots like this. This type of information is simply not present in these figures. And what this will do then for you is, number one, it will try to address room resonances and standing waves. And these are typically in a bit lower frequencies. It can also be later, and it tends to arrive from all directions in the room. Then, as we are working in the time domain, we can also try to deal with things like misalignment of transducers in the speaker that are either because of the speaker design itself or the passive crossover, as well as early reflections. And those are typically mid to high frequencies and have the common property that they all arrive from the same direction. And they are in time close to the direct wave. Then lastly, we also have the late reflections or room reverberation. They also arrive from all directions, and in an individual point, you can't really do anything about them. So what you can hope to do here is to change the coloration, really. And those are the four aspects that a room correction system like Dirac Live can hope to address. And hopefully, or I certainly hope so, most of you have used Dirac Live and AudioControl before. I will just quickly go through what the new software looks like for those of you that haven't tried it. When you start it up, this is what it looks like. In this case, it says Dirac Research Dirac Live Processor. So that's just the software we have that acts as a PC that can do Dirac Live. If you have an audio control unit on here, it will pop up. So it's the same software regardless of what Dirac Live unit you're using. If you have 3 different audio control units, they will all pop up here and you can choose the appropriate one for whatever calibration you are currently doing. Also new here, which I hope that some of you, especially installers, will find it useful. If you see in the upper left, there is a button that says IP. In case on site there is some kind of networking issue, you actually have the option here to just manually enter the IP address of the AVR itself, if it's not found, for instance. And this it happens rarely, but some consumer level routers doesn't deal with the UPnP protocol explicitly or that well. And then you can use this as an override to be able to complete your work. So when you have chosen your device that you want to calibrate, you have the same step as in the old software. You need to choose whatever recording the device you want to use. And this depends a little bit on the equipment. In this case, we have several options available on a PC. If you have a unit that supports hosting the microphone, that will also pop up here as a microphone. So make sure to choose the appropriate one, same as in the old software. And in the case it's a unit that ships with a microphone that you can connect to the unit will automatically upload the appropriate microphone calibration file to the software. And if you choose to have another measurement microphone for which you have a calibration file, you can also choose to load that one manually. Then we have the volume calibration step. And really the purpose of this is exactly the same as in the old software. It's to make sure that no one speaker is really soft or really, really loud. you basically want all of them to be within 10, 15 dBs of each other, because otherwise you will probably run into some kind of issue where the recording is clipping or not loud enough. And this is going to change between all points. The bigger your install, the bigger a problem this tends to be. And usually it is because the subwoofer levels, the knob on the sub itself is either too loud or not loud enough. Passive speakers tend to be fairly similar. And that is really the only reason to change anything here. Just check your subwoofers and a couple of the full range speakers and make sure that the levels are sane. And it's really to make the rest of the process easier. Once that is done, you need to select your listening arrangement. And this is similar to the seat selection in the old software where we had, it was some kind of chair, sofa, or auditorium. And you have all of those here as well. So make a selection that is appropriate for your type of install, and then go to the measurement process. We have tried to make it easier to understand where the different measurement points are illustrated in relation to each other. The most important thing to consider when it comes to measurement point is to move the microphone. It's not necessary to religiously follow these exact positions. It's mostly a reminder to make sure to spread out the measurement points in the listening area. Otherwise, your results may be unexpected. And as in the previous software, the first point is different from the other ones in that that is the one point where the arrival time of all speakers will be simultaneous. And if you sit down and think about it, it should be geometrically clear that there can only be one such point. And that is the first one. So that should go in the middle of the sweet spot to make sure that the timing between the speakers are right. Then any remaining points that you do should be well spread out throughout the listening area. Also, in the very latest release, it's actually not present in this screenshot, and that was due to popular demand. We have added a timer feature. So you can set 2, 3, 4, 5, 10, 15, 20 seconds delay before the measurement starts, in case you are really fed up with listening to these sweeps. And you can set 10-second delay, and that way you can actually leave the room before the test signal starts to play. And when you have done your measurements, you come to the filter design page, which fills the same purpose as in the old software, but we have reworked it to hopefully make it easier to understand. You have your output channels and your speaker groups, same as in the old software, only it's a little bit more explicit. And you set the target curve just the same as you did in the old software. And that's basically it for the new software. So it tries and does everything the old software did. We think it's easier to use. And it certainly allows us to add more features to it in an easier way. The old software was not really meant to get new significant features like bass control. So Dirac Live Bass Control, that is our attempt at solving a major, well, task, if not a problem or issue, when you come to home theater. How do you integrate your subwoofers as good as possible with all of the full range speakers simultaneously? That's a daunting challenge, and historically, people have used experience and patience and a measurement microphone and some software trying to get the phase knob right that may be present in your subwoofer, and that's basically it.
Jacob, for a
yes.
point of clarification, I think initially this was discussed as Dirac with bass management, and now it's bass control, correct? I mean, I want to make
sure. Yeah, exactly.
They're asking, is
Yeah.
there another one I missed or anything like
No,
that?
no. Exactly. We call the feature base control just to let people know that, yeah, it's probably base management, but it's also doing more.
Gotcha. No, you guys did a
Yeah.
good job branding both sides of it. So people were asking for the third one.
Yeah. So I will try to describe the problem statement a little bit and possible solutions and how those are integrated into Dirac Live base control. So what we see here are front left, front right, and center in a home theater setup. You can see that the speakers are full range. We have used Dirac Live without base control to get and set the target curve to flat. And the reason we set it to flat is not because it sounds good, but because it's easy to read the plots and understand what happens. So the black trace is the average magnitude response, and the blue traces are 21 individual measurement positions. So as we asked for the target to be flat, we can see that on average, we did achieve a flat target, exactly what we asked for. But the individual positions are all over the place. And you can see that down in the base, they are actually grouped together according to how the wavefront covers the different measurement positions. So this was actually measured in a grid. And this is the effect that room modes will have on your sound. In one point, you're going to have overwhelming boomy bass, and in another one, there's going to be a complete suckout. It's also interesting to note here that since these are all three speakers on the same wall, in low frequencies, we see that they have the same behavior. They all have the same room modes and nulls. So, all right, it's nice that it's flat on average, but ideally we'd like everyone to have the same amount of bass. And looking in this example then, we added 4 subwoofers. So one is on the same wall as the other ones, or as the full range speakers. One is behind on the opposite wall, and then there is 2 on the side walls. So we can look at, for instance, the top left plot. That's the same plot for the subwoofer that is on the same wall as the full range speakers. And it's interesting to note that in low frequencies, it behaves exactly the same as this, because it's all about the room in low frequencies. So it's expected that it behaves the same. And in the lower right, you can also see that we have a grouping, but it's different. And that is the speaker behind the listeners on the opposite wall. So it's still grouped because it traverses the measurement points in the same way, only from the other end, so to say. And the top right and the lower left plots are the side subwoofers, which excites the room different in these measurement positions because they traverse the measurement points from different angles than if you go straight ahead or from straight behind you. Now, people tend to add more subwoofers to get better bass, not to get more bass, or maybe you want more bass too. But the reason most people decide to use multiple subwoofers is to get a more even bass response. And there is a result, I believe, that's a theoretical result that says if you add an infinite amount of subwoofers, you will get perfect bass, whatever that means. And I'm sure it's true. It's also not very helpful because you can't fit them and you can't afford them. So 4 subwoofers seems to have been deemed to be making a significant difference. So looking at this then, this would be 4 subwoofers and 3 full range speakers, each individually corrected for using Dirac Live. So we have 7 flat responses. And this is the sum. And the interesting thing to note here, of course, is that the variations, that is the delta between the black trace and all of the blue ones, are still there, even if we in practice now have 7 subwoofers. And adding 7 things that are flat, it doesn't add up to flat, then this curve will also be flat. So what's going on here? And again, the reason flat plus flat does not equal flat is in the time domain. It's the phase of the system. They aren't in phase everywhere, especially not at the same time. And we can see that the seat to seat variation is not really what we want it to be. It's reduced, but the really big room modes, they are all still here in the really low frequencies. So what we want to achieve here is something like the lower picture here. That is the same set of speakers calibrated using Dirac Live with bass control. And the interesting thing to note here now is that the black curve is flat because we asked for flat, but also all of the blue traces are really well collected around the average in low frequencies. And the way we solve this problem is through a 3-stage process where number 1, we use a cloud-based AI algorithm to calculate gains, delays, and all pass filters such that the set of all subwoofers plays together in such a way that the seat to seat variation, meaning the difference between different measurement points, is as small as possible. Number 2, we look at pairs of full range speakers, because this group of subwoofers, you can think of them as one super subwoofer now, but they will still have different phase relation to each full range speaker. So it's not really possible to cross them over successfully to each speaker at once. And in some cases, such if you have a 2.2 or a 2.4 system, you really don't want to have any phase difference in the bass between the left and right speaker either, since most music, for instance, tend to be mono in low frequencies. So what we do for that is that we calculate pairwise all pass filters between full range channels such that the phase difference between them is minimized at the crossover point. And that allows us to go for the last step, which is to calculate the crossovers and all pass filters between pairs of now phase coherent full range speakers to the set of all subwoofers. Meaning it's possible to have the right phase relation between each full range speaker and the subwoofers at the same time. So the total calibration now has 4 steps, where the old one really only had 1. So first, each output channel gets its own Dirac Live filters, same as always. Secondly, we calculate filters for the group of all subwoofers such that they cooperate as well as possible. And thirdly, we look at pairwise full range speakers to minimize the phase difference. And in the last step, we calculate all pass filters such that the group of subwoofers blends as well as possible with these pairs of full range speakers. And while that sounds like maybe it's going to be a lot more work and more controls, I'm really proud by the way we implemented this in the software. Really, we only added a single new user control, which is the vertical line that you see here. It says 90 Hertz. So that is something that you can drag left and right as you like. And that is the crossover point that you want for a particular group of full range speakers to the subwoofers. And the interpretation of the target curve have now changed. When you set the target curve and you use bass control, the target curve is the target you want to have after bass management. meaning it's not necessary or even possible actually to set the target curve for individual subwoofers. Because honestly, why would anyone care what the target is for a particular subwoofer? In order to get the best possible sound, what you're really interested in is what is the target after bass management. And from that target curve, the target that is actually used for the subwoofers is calculated behind the scenes. So it's not something that you need to consider anymore. Just set the target and the software will calculate all of the filters for room correction as well as for bass management for you in one single go. So in the area called A, in this example, that is where your subwoofers are playing. B, both of them are playing, and in C, it's only the full range speaker that is playing. And of course, you still have the same curtains as was present in the old software, here at 29 Hertz and at 20.6K, where you can limit the correction to a particular limit. And yeah, I believe that's what I had. I'm sure you will have a load of questions though. You want me to make you the host again?
Sure, Jacob. Yeah, there's a few in the chat room here. We can work our way through here. And by the way, just so everyone knows, so the bass control module is included now, of course, with the Dirac, that when you order an audio control processor. And we do provide the microphone. I think that came up as a question from someone. Let's see, Jacob, one of the questions was, since the human body absorbs energy, do you recommend calibrating a theater with someone sitting in each chair?
Well, if you want to be really strict about it and you expect every chair to be seated, it's not going to hurt you. But it's also not going to make a huge difference unless you have occlusion effects. For instance, you have a person in front of you covering the line of sight from a front speaker. But then again, who are you calibrating for? Then you need to choose.
Gotcha. So there is an impact, but I guess the issue will be how much advance you want to do.
In most cases, the impact can be, well, you don't need to consider it.
Gotcha.
And if it does have an impact, then you have difficulties since the impact is going to be different on a seat per seat, because a person in the front will never be occluded by the front speaker, but maybe from the rear speakers. So it's going to be different in every seat.
I've seen a few live recordings in auditoriums where there's no people in there. So what they do is they take sheets of plywood and put acoustical materials over them. They put them over all the chairs, because in those large areas, there's certainly a lot more reverberation and reflection and stuff that affects that. So I guess it depends on the size of the room. And if the room is properly treated acoustically, you know, you're probably off to a good start. If it's a giant room that's got glass and tile and wood, which is going to be tough to begin with, it's probably a good starting point. So
yeah.
Okay. Next question here from Sean is the difference between Dirac, how Dirac calibrates a room versus Room Perfect.
That's a good question. I must admit, I'm not 100% sure how Room Perfect works. And it's always difficult because when you ask someone about things, I'm not always 100% sure about the answers I get. But the main difference would be that I guess that Room Perfect is aimed at particular speakers, because that's mostly used for Lindorf systems and are aimed at Lindorf speakers, which is actually an advantage because then you know more about the equipment that will be used, so you can make stronger assertions. From listening tests, well, I would advise you to ask Google for comparisons rather than me telling you. But the difference really is that Dirac Live was built to be more general purpose for more types of systems in more types of equipment. And I don't know a whole lot about Room Perfect. I know there is a small crowd that swears by it and really likes it, and then that's good for them. In terms of what they actually do, yeah, I'm not sure.
There's definitely different levels of calibration that are out there. I think maybe a future version of Dirac Live, you'll be able to download all the profiles of speakers, right?
Yeah.
Then you know what you're working with. So
yeah.
no, I think in our experience, AudioControl, we're a signal processing, and obviously we cut our teeth with equalization many years ago that then gravitated into amplification and processors. And I've watched calibration go from your standard frequency EQ, which in a fixed situation can work fine, but when you get into higher frequencies and stuff, it gets a little more complicated. And the thing I think that caused us to really embrace what Dirac was doing, because it was the first calibration system that really looked at level and time and then frequency, as opposed to manhandling a frequency, which is what some other calibration systems had done in the past. So all of a sudden you got things arriving in time and phase balanced. So then your equalization becomes a lot more judicious. So the result, of course, of trying to get that smoothness from point to point and balance and so forth is really, I think it's really good from that. I think one of the new features that the system has now too, Jacob, is the ability to save multiple curves. So people can actually go through and I guess create, a couple of different scenes, whether it's a balanced scene or maybe a little more, in North America, we tend to have a little bit more dynamic bass response than, other parts of the world. I'll say it nicely. So sometimes when you get a system that's perfectly flat, it may not be what the client's looking for. And I think one of the things we've always liked about Dirac is your ability to capture all that data and then the ability to create that target curve, and then for that data to go up and create that inverse curve that gets put in there. So I think from a process standpoint, and yeah, you can certainly get into the minutia with different types, and believe me, we make audio analyzers and stuff that'll get you there. But I think from a calibration standpoint for what you guys are trying to do, Dirac's a really, really good solution. So, but good question there.
Yeah, I mean, in the practicalities, there are quite a few differences in terms of what you can and cannot do. I would say that for installers, Dirac Live is probably second to none for the really big installs, because as far as I know, it's the only system where you can connect the microphone to the laptop and put away the unit in a control room somewhere, for instance.
Yeah, did everybody get that? That's always, to me, I'll talk about the math of Dirac, but I mentioned the microphone does not have to run back to the rack. The crowd usually goes wild from that standpoint. So it's, but I think from a user perspective, it's great there.
Yeah.
Excellent. Let's see. One of the questions here is would you still use room treatment for helping out the bass control, or is that more or less obsolete by bass control?
It depends on the amount of room treatment. Bass control works in low frequencies, and for minimum effort and money, typically dealing with high frequencies passively works pretty well, while doing the same using room treatment, passive room treatment in low frequencies, it's difficult, it's bulky and expensive. But of course, room treatment will never ever hurt. But low frequency room treatment, it's not easy, and it's really invasive, both to your economy and to your room. But if you have the option and want to do it, sure, go for it. The combination will always be as good or better than only using bass control.
We used to teach classes here at our factory. We called it Train in the Rain, because it rains here in Seattle, although now it's smoky, so it's a little different. But and we talked about room design and speaker placement and room treatment. And it was interesting because people would come to the class, and some of the rooms they were working with were really challenging, 10 by 10 by 10, and speakers shoved in the corner and stuff like that. And we taught them enough elements, and beforehand they'd use a lot of processing, whether it was our equalization or whatever, to kind of manhandle the room. And then they would go back and redo a room, and then their projects got better and better and better too, where all of a sudden they go, I'm not using as much processing. And I go, well, tell me what you're doing. You're right. There's a a huge chunk of budget that's gone into the room correction, or excuse me, into the room treatments, the seating locations. A lot of things are calculated better and all that. I said, but that's because you're learning, you know, in a perfect world, in a room with minimal amount of reflections and such, the amount of that gets less and less and less. But at the end of the day, you know, these are lifestyle rooms. So that you guys remember the old TDK commercial where there's a guy sitting in a chair with the wind blowing, and that one chair is in the middle of the room and all the speakers are aligned perfectly and all that. That's an anomaly. I think we're dealing with areas where we've got, you know, 5 and 10 people that want to sit there. You know, I know in my family, whoever rushes to the middle seat gets the best seating location. So, which of course I notice it more so than my children do. But so that's I guess it depends on the budget. And you're right. There's some room treatment products that look wonderful, but and then some of them, you know, might be a little bit obtrusive or budget oriented. So let's see here. Here's a technical question. Is there a way, someone's on, I can hear somebody hissing, if you can turn off your mics. Is there a way to raise room gain so we don't have to set the volume so high after Dirac is run?
Is there a way to set the room gain?
So we don't have to set the volume so high after Dirac is run. So I guess, yeah, I hear people, yeah, after they get done calibrating, which in a lot of cases, obviously, is you're removing energy more faster than you're going to be adding energy. So if you did an A/B of overall level, you might feel that a post-calibrated room is a little quieter. Is there a different way to approach that?
Yeah, so that's one thing. And also, though, the big difference, if you compare the system out of the box versus out of calibration, that makes you need to crank up the volume more, is that the filters are digital filters. They are applied in the digital domain. And there is only a finite number of different numbers. And since we want to change the signal and the content can be assumed to use the whole dynamic range, what needs to happen is that there is what is called a DSP headroom, typically around 10 dBs, that is needed to make sure that the output signal doesn't clip in the digital domain, because that sounds really, really bad. And that will lead to a volume difference. So that's where the main source of lower volume is probably coming from.
Is it, I don't want to use the term best practices, Jacob, but could someone, when they create the target curve, could they then take that target curve and maybe move it up 1 or 2 dB and then use that? Will that accomplish? I mean, okay, admittedly, I've cheated and done that. But at the end of the day, the client is not A/Bing before or after and all that. The client's just listening to the response. But you're right. Being an equalizer company, you know, for years, people would say, oh, I turn it on. And when you do a really bulky loudness curve, they go, wow. But it really wasn't giving them the balance, the dynamics. They just thought it was getting there. But if you do a balanced system and you're taking away energy that's masking things as opposed to boosting it up, the overall level might be down a little bit. But I got to say, I mean, from the first time I heard Dirac system, where it was a lot more balanced, the woofers literally disappeared in the room. You know, it's just a lot more of a flow. So, but no, it's a good question. I think there's probably we've talked about maybe having Jacob and the team look at doing a more advanced Dirac setup training afterwards. This was a perfect opportunity today to kind of introduce everyone to base control. So we'll use that. And if we do something a little more advanced, we'll certainly make sure everyone knows. Let me run through these questions here. I want to certainly make good use of everyone's time here. Is there a diminishing return by the number of subwoofers? Is there a sweet spot, e.g. one subwoofer gets you to 60%, 2%, 2 gets you to 90%, 3 only adds, interesting.
Yeah.
So if you have 10 subwoofers, is it better?
So that's a very good question. Unfortunately, I don't have any good answers here. It's going to depend on the room, on the subwoofers themselves, where you can actually place the subwoofers, because most people can't do perfect speaker location every time unless you have a dedicated space. So it depends a lot. But 4 seems to be empirically by the whole industry a good compromise in terms of number of subwoofers for maximum performance, if you will.
And I found cosmetically too is, you know, early theaters that I've been involved in would be the one large subwoofer. And in a lot of cases, that one woofer is feeding the room, and you can be pushing that woofer pretty hard in the amplifier. Now I see more theaters. I kind of recommend, 3 or 4 smaller subwoofers. So now the client doesn't have to find a monster, woofer in the corner of the house. And at the end of the day, the amount of sub-frequency drivers that you have, I think, is relative to the size of the room. So, you don't want to take a single 12 and try and fill up a 2,500 square foot room. You're going to work that speaker very hard. But if you put 3 or 4 of them around the room, so it's less obtrusive cosmetically, but it's going to definitely put more energy into the room. And just from a sales perspective, I would probably rather sell 4 woofers than 1, but just a thought. Let's see, got a couple more questions here, and then we'll free you guys up. How long should an integrator allow for calibration when creating a quote for a client?
That's a good question. It depends on what else, and of course the size of the room, the number of output channels. For the room correction purposes itself, it's when you know how to do it, you can probably do it in half an hour for a big seating area and a fair number of speakers. But then it depends, of course. Each additional output channel that you actually use adds a little bit of time. Every measurement will be 5 seconds longer, and you're going to do multiple measurement points. So let's assume that the measurement time for big systems increases by about a minute for every additional speaker. So a stereo system would then be 2 minutes to measure, minus moving the microphone, and the 16-channel system, that's going to be quarter of an hour just to do the measurements. And then how much time you feel that you want to spend setting up potentially multiple profiles, one for classical music, one for that night when you decide to rewatch every single Rambo movie. And
No, I think what I've seen from most dealers, they'll budget in a half day, 4 hours to allow, and it depends, because some of it is the initial taking attendance. When you go in and you get things set up and you run the system, it needs to make sure all the speakers and everything is properly connected. I know I've done that many a time and found out I had a speaker disconnected. So you've got to allow that kind of time to make sure things are positioned where they want. Honestly, if the client wants to sit there and peek over your shoulder, then it's an 8-hour process. If you're doing it on your own with your team, then it's a lot more efficient. And one of the things, by the way, I think some of you guys have taken advantage of this already, but if you're doing your first Dirac calibration, or you haven't done one in a while, please reach out to our tech team. Well, number one, look at our knowledge base on our website. We have kind of a step-by-step guide in terms of how to get up to speed on what's going on with to calibrate your Dirac system and Q&A. And secondly, if you need to, we can log on via TeamViewer onto your system and kind of walk you through it a little bit. Preferably your client isn't peeking over your shoulder. You're doing it in your showroom or practice session. So there's some opportunities there, I think, from the training thing. And we'll try, and I want to work with the team at Dirac to create some more videos to get into that a little bit more advanced stuff. So let's see.
Chris, can I jump in here? John Parker. I couldn't figure out, I typed to chat, but I couldn't figure out how to send it. So my question is, Floyd Toole wrote a 30-page paper on subs and said the right number for any room is 4, but in most cases, 2 can be nearly as good as 4. And I wanted to know what Jacob's viewpoint on that is, because I'm sure he read the paper too. Pretty much everybody's read that paper.
Yeah. So, yeah, it's a very good paper, and what it says in there is true. And also in the plots I showed, putting 4 subwoofers in a room is gonna give you that performance, like I showed you, and that's not what you want. So the question about bass control here really is, how do you make the most of those 4 subwoofers? Another question, which I also don't have the answer to just now, would be interesting. How do 4 subwoofers with no bass control compared to 2 subwoofers with bass control? And again, the positioning, where can you place the subwoofers? How big area do you want to have even bass response in? Will depend and determine if you actually need 4 or if 2 is going to be good enough. Like you said from that paper, in many cases 2 are enough. Many, not all.
Okay, one more question, one more statement. Actually, somebody corrected me, AJ. The guy in the chair that I was talking to was Maxell Tapes, not TDK, so my apologies. I don't believe either of those companies are in business anymore, but I want to make sure I give the appropriate credit to those companies. And John here is, why do you have to take third-party control systems offline for the Dirac software to be recognized? And I think this relates to when people may have a C4 or Savant or something else running while Dirac is running, and they have to take that down to kind of expedite the calibration process. Any thoughts on that?
There is nothing in our system that makes it so, as far as I know. It could be a particular to this implementation itself. This is not something I have heard about before.
Gotcha. Yeah, we have noticed, at least for, and there might be more of the network traffic, but sometimes if you've got multiple, if you've got a control system, the Dirac Live can operate like control system also. So sometimes not on there. So, but cool. Okay, well, we are at 9 o'clock, folks, which is definitely a excellent conversation. Good questions. Like I said, I appreciate everyone being on here today. And if you have more audiologue you want to talk to, please go visit our website. You know, we have certainly our tech team at the office is happy to help you out. If you use the Dirac or AudioControl processor with Dirac, wonderful. If you haven't, let us know. We'll be happy to kind of get you connected with the dealers or with our sales representatives in your market. Please spend some time viewing the AudioControl booth, our virtual booth. We've got some interesting information there. And I thank everybody for coming today. And Jacob, if you can stay on at the end here a little bit, if there's any fine follow-up questions that people want to stay on and ask, that's great. But I want to break everyone free. But thank you everybody for being involved today. It's excellent.
Yep. Thanks, guys.
This is Niklas, also from Dirac. I really love the last question. All the base management or base control systems from different vendors, should they be turned off? So please, Jacob, this is a good question.
Well, yes, they should. Just like the person who wrote the question also proposed that, yeah, it should be turned off, because depending on what those systems do, you don't really know. So better just to treat it as a regular subwoofer and let base control do its thing. Otherwise, there's really no knowing what the result is going to be.
Cool. All right. And we have some hanger-ons here, but all right. Well, guys, thank you. By the way, we're going to have a training from Dante actually here in a couple hours, where there's a different invite. So go to the AudioControl website, click on the events tab, please. Dante has absolutely nothing to do with room production, but certainly an innovative technology in its own right. And then about half an hour on the AudioControl main Zoom room, I will be hosting a training on our new Director 2.0 platform. So that'll be exciting as CEDIA can be and such. So, but thank you again, everybody, for calling in today. I think this is one of the better trainings that I've seen. Jacob, Nicholas, guys, thank you very much for participating.
Thank you.
I have to say, the power of Zoom. When the first time Jacob and I did this a few years ago in San Diego or somewhere, it took us all to get together. Now it's nice we can do this a lot more conveniently for everyone. So
it is.
All right.
All right. Thanks, guys.
Thank you, folks. I appreciate it.
Bye-bye.